Let's talk about hedging portfolio beta using linear regression. Today's video is coming from code out of this book here, Python for Algorithmic Trading, first edition by Jason Strimble. And I followed it pretty much to a T, so this is definitely not my code, but I found it fairly interesting because I followed his recipe. I didn't get the same outputs that he had. I made some additional adjustments. I think in general, the code is sound in terms of like calculating beta and using it as a way of gauging how to reduce your risk. So this is an idea where you're going to have a portfolio and then you're going to hedge against beta to help improve your returns. We're going to be using NumPy, Pandas, stats model, the regression, obviously, and then I've loaded in some plotting. We're going to use Y Finance, so take it with a grain of salt. If you want to use, more accurate data, go ahead. Y Finance, I think, is great for things like this. And recently, I've just really enjoyed setting my start and end dates using the datetime import packages. Um, so yeah, I think that'll do fine. But you can also just set hard dates. But I found making videos like this, it's a little bit nicer to set up my start and end date using date time so that whenever I make the video, it's using the most current dates. In the recipe itself in the book, it's using 2020 to 2022. Obviously, we're in 25 now, so it's a little outdated. The portfolio is the same though. Um, it'd be interesting to like make your own portfolio. I was thinking of doing this on crypto, but thought it would just be better to make the video instead. SPY is the, you know, S&P 500 ETF, like overall market ETF, and this is what we're going to be using as our beta or the thing that we hedge against. So let's go ahead and download all of our symbols here. And if we take a look at our data frame, you can see we have our ticker dates, our symbols, and the close for each of the days. And I could scroll over, but we have the rest of the symbols as well, right? Johnson & Johnson, MRK, and S&P 500. So the benchmark returns is our data. We're going to take out SPY. We're going to calculate our returns as the percent change over each row and then drop any non-values that we have. So this is the returns for SPY here. Excuse me. Did I say pop out? I just mean we're on like the pop function just takes that column, the SPY column. We're going to do the same thing for our portfolio returns. We're going to take the rest of the data, calculate the percent change, drop in a portfolio. Cool. So this is our portfolio returns. And then let's plot it. Cool. So you can see here our portfolio returns, and then we have our benchmark returns as well. SPY that's return, and then we have a symbol in here that has quite a big drop in terms of returns. That's probably going to throw things off, but whatever. Ideally, we can play around with this code and get it to a point where maybe this outlier doesn't exist. So then what we need to do is create a function that calculates the linear regression of our returns against each other, and then take the parameters and spit them back out to us, right? So x will be our alpha, beta will be our y, right? So x is our first parameter, second parameter, right? That makes sense. So you can see here our alpha is actually -1.5, I guess thousands, hundreds of tens of thousands here, and our beta is 4.9, almost 5. If we plot the linear regression with our Here's our portfolio returns. Here's the SPY returns. You can see that there's a linear regression in accordance to that. And they're sort of clustered around no returns here, which is kind of interesting. I was reading that if you do not set a constant for your benchmark returns, it will force the intercept, which will skew what you've done. The interesting thing, though, is that I have created the constant here. And I'm not unsure if it's still forcing that that intercept around 0. So that's I'm not sure what I'm doing wrong here because I'm following the recipe, but I have a intuition that it's not doing the desired outcome. Nevertheless, when we calculate the hedging beta in our portfolio, it'll be our returns. Essentially, we're gonna subtract a beta from our portfolio or benchmark returns and portfolio returns. And those values are going to be contained in the hedged portfolio returns. And then we're going to pass through that hedged values through our linear regression function and only return the beta after that. So our beta would be negative 3.46, or excuse me, I need to actually run it. So our beta would be negative 6.7 here. And then what this really should be is 0. So this is why I'm not understanding why I'm getting a different outcome, because this is our hedged portfolio right here. What's happening in this code is that it's taking our portfolio returns and it's calculating the beta and subtracting that beta from those returns. So we're hedging beta so that we can reduce our risk and essentially take our portfolio risk to 0. But what this is saying is that we've actually reduced our beta to negative 6.7, if I'm understanding the the math right here, which is an improvement because beta was 4.9 when it was unhedged. But to get a better idea of what our returns would look like hedged or unhedged, we can do what's called an information ratio, which we pass through our portfolio and benchmark returns. And our active returns is the portfolio minus the benchmark, and our tracking error will be this calculation. That's standard deviation, and it returns the average divided by this calculation of our standard deviation. So when we pass through our hedged information ratio, it's taking our hedged portfolio returns, which we've calculated up here, which is taking out beta from our portfolio, and it will do this calculation here to get our information ratio. And then we do the same thing with our unhedged. So we're just passing through our portfolio and our benchmark returns. So the hedged information, excuse me, I didn't run any of these cells. Got outputs from when I was building it. So our hedged information ratio is just the negative of our unhedged, which, if my understanding here is that it's inverted, the hedged information ratio being negative is essentially is a better way of calculating what taking out beta from your portfolio has done to our portfolio returns here. I could definitely learn more about information ratio, and in other videos I hope to sort of continue to follow along and post videos like this similar to what I'm reading here in this book. I just want to call out that my outputs are not the same for what he's doing, but I'm also doing things a little bit differently. For instance, like we've got this outlier here in our portfolio and the returns. I don't know if that has something to do with the outcomes that I'm getting. I'm also using totally different dates than what he's using. and I'm also using a different data set. So I don't think he's using Y Finance to get his closing prices. I think he's using a different data source, but it is a little bit more involved. This is just a quicker, albeit dirtier, um, process to get there. Nevertheless, I think the idea is solid. I think more often than not, traders, especially when you're getting into it, like hobbyists or learners, are so focused on calculating alpha that they forget that they can increase their returns by reducing beta from their portfolio. And this seems to be a really good introductory to those concepts that I hope to continue to learn about and share with you guys. Sweet. I hope you enjoyed the video. Let me know what kind of changes you'd like to see here. I might make a second video similar to this, but we use crypto instead of stock equities. I'll see you in the next video. Bye.